right, here we're looking at section 10 of our algebra review section. So our learning targets, we're dealing with a lot of rational exponents here and radical equations here. So we're working with some nth roots, right? And we've worked with square roots a lot and some cube roots. Now we're just dealing with nth roots. We're going to be simplifying radicals. Along that, we're going to rationalize denominators so we can simplify completely. Then we're going to look at some radical equations and how to solve them. And then finally, simplifying expressions with rational exponents, really fractional exponents. Okay? So first, working with nth roots. So I know square roots often because I've dealt with them. But here we're dealing with roots that are not a 2 or a 3, really. So a and b are going to be non-zero numbers and that are greater than 0. That nth root is how many times do I multiply b by itself to get a? That's what that question is really asking us. So here are some examples. So I'm looking at the cube root of 8. So my question is, what do I multiply by itself 3 times to get 8? And that answer would be 2. So here we go. Again, a cube root. What do I multiply by itself 3 times to get a negative 64? Well, that's a negative 4. So now here this is a little bit more complicated, right? Because now I have a 4th root, and I also have a fraction. But still, what do I multiply by itself 4 times to get this value? And here's 6th root. What do I multiply by itself 6 times to get this negative 2? And here is missing an equation. This is a bad example. Don't look at that one. That one's missing our actual example. Okay. So in general, if I'm having these values, my n, right? So n is going to be greater than or equal to 3 is odd. And then we're evens. So if I have an even exponent or an even root, I know that I'm going to have a positive solution. If it's odd, it could be either positive or negative. That's really what that's saying. So we can also use our calculator, which looks something like this if you're using a TI. You can also use Desmos that will help you solve these as well. But our calculators work just as well. Okay. So now we're going to simplify some radicals. The big thing to note here is when I'm multiplying inside my radical or dividing, I can separate them both out. And then if I have a to the m inside my radical, that can also be the nth root of a with the exponent of m. So just some simple ways I can pull them apart. This might be handy to have in your notes if we haven't dealt with these much. Okay, so let's look at this example. Okay, so we're going to be simplifying this radical. So the first one I'm looking at is the square root of 32. So I ask myself these questions. Okay, and here's why. I ask myself, does 4 go into 32? Then does 9 go into 32? Does 16 and 25? Because I know the square root of 4 is equal to 2. And I know the square root of 9 is 3, square root of 16 is 4, and the square root of 25 is 5. So I can start asking myself these questions. So here I know that 16 goes into 32, so I've got 16 times 2. So then I can split those out, and since I know the square root of 16, I can go ahead and simplify that piece as well. Okay, so now let's look at this as well. So now I'm looking at cube roots. So now I say, what can I multiply in? Well, I know that 8 is a perfect cube, and 8 goes into 16 evenly. So I know I'm going to end up with 2 times the cube root of 2. Okay, so here we go. So now I can break things into chunks. So here I'm dealing with the nth root, so the cube root here. So first I want to deal with the numbers. And again, I know that my negative 8, is a perfect cube, so I can pull that out. And since this number here, my root is a 3, I want to break everything else in chunks of 3. So I have an x cubed, but then I'm left with an x. Okay, so the things that I can eventually pull out would be this negative 8 because I know the cube root of that, and I also know the cube root of x cubed. So those I go ahead and I pull out, so I end up with a negative 2x because that's the cube root of negative 8x cubed. This 2x has to stay inside my radical sign. Okay, and here's my one final little example. Whoops, wrong button. Let's try and move this up a little bit. Okay. So here again, I break things into chunks, and now I'm looking for the fourth root of things. So I look at each of the numbers individually, And I know that I have to break the x's into groups of 4. So I can go ahead and do that and simplify that. And I know that I'm dealing with the absolute value here because this is an even number. So that will help me out as well. Okay. So now let's look at this next example. We're combining some like radicals. Okay. So I have a negative 8 times the square root of 12 plus the square root of 3. So first I want to simplify the radicals that I have, which the square root of 12 can be simplified into 4 and 3 because I know the square root of 4. So I can break those apart. So now I end up with a negative 16 times the square root of 3 plus the square root of 3. So now these are similar, and I can just go ahead and combine those terms. So here's my next example. I have my 8x to the 4th plus a negative x plus 27x, and all of those are the third root, right, my cube root. So I go ahead and I break each one down individually as much as I can, right, into my chunks of 3. So then I can go ahead and simplify and pull out things. So here in this first one, I know that 2 is the cube of 8, and x is one part of the cube root of x to the 4th with that x still inside. I can pull out that negative 1, and I know that I can simplify this last term as well. So now that they all are written in cube root of x, now I can just combine them and end up with my final solution there. So now we're going to look at rationalizing denominators. And we always want to rationalize a denominator when we have a radical in the denominator because that's not completely simplified, so we need to continue working on simplifying. So if I see in the denominator just a simple radical, I multiply everything, so the numerator and the denominator, by that radical. If I have something that I'm adding or subtracting, I have to use the conjugate. So I have to change the sign and multiply by that. Okay? So you'll see that in both of these examples, in all of these really. Okay, and here we can use the simpler or we can go this way too because it's just a radical, so I can multiply by that as well. So we're going to look at some examples. Okay, so we're first rationalizing the denominator, and I know I need to do that because I see radicals in my denominators. So let's look at these solutions. Okay, so I see I have a radical in my denominator, so I know I need to multiply by that radical. So I take my entire fraction, I multiply it by the square root of 2 over the square root of 2, and simplify. And I see here that I have a 4 divided by 2, which can simplify to 2. Okay. Again here, I have a simple radical in my denominator, so I need to get rid of that. But I also want to make it a little bit easier to follow because it's a cube root. So I need to use my cube root of 4 here, which will end up giving me the cube root of 8, which will simplify to 2. So that's why we picked that cube root of 4 there. Okay, in this last example, here I see I'm adding or subtracting in my denominator, so I have to use the conjugate. So I switch the sign, so it'll be the square root of x minus 2. So now I take that and multiply, again, both my numerator and my denominator by that, so then I can simplify that out a little bit more. Okay, and that's what I end up with. So here, when I have this, I cannot just take this exponent and distribute that in. Remember, it's the quantity of the square root of x minus 2 times the quantity, the square root of x minus 2. So that's how I can multiply out and get this entire numerator here. Okay. So now we're going to be solving a radical equation. So remember, solving is getting x by itself. So the first thing I always want to do is get that radical all by itself. So here we see I'm subtracting 2. So the first step I want to do is add 2 to both sides. Well, now I see that I have everything alone, so I'm going to go ahead and take everything to the third power. And I pick the third power because that's the root that I'm taking here. So now I raise each side to the third power and simplify. Well, now I just have a simple linear equation that I can solve. So I add 4 to both sides and then divide both sides by 2. So then we can go back and just double check, but that's the easiest way to solve. So I always want to get my radical by itself and then kind of follow my steps. So now we're going to be simplifying some expressions with those rational exponents, so my fractional exponents. So remember, if I have a to the 1 over n, that's the same thing as the nth root of a. Okay? So let's look at this. So if I have 4 to the 1/2, since this is a 2, it's the square root of 4, which equals 2. 8 to the 1/2, again, since my denominator here is 2, it's a square root of 8, which I can simplify following the steps I just did to 2 times the square root of 2. Here, since my denominator is 3, it's the cube root of that negative 27, and here the cube root of that 16. So I can work backwards and forwards with that one as well. So here's my other definition rate. So if I have another fractional exponent, so m over n, we've been dealing with ones, so this numerator can either go inside here with my base or outside my parentheses, either one. Okay, so again, my denominator is 2, so I'm taking the square root, and then my numerator can go ahead and go outside here. So I'm going to end up with the square root of 4, which is 2, to the third, which gives me 8. So here again, my denominator is 3, so I'm taking the third root. This numerator becomes my new exponent out here. And you can follow along these as well. Generally, when we have negative signs, the negative is going to go with the numerator in the fraction. So now we see, now I can have several terms in my equations with rational exponents, and I want to look at each piece a little bit separately, right? We like to break things down into chunks. Okay, so first I'm going to leave this first part alone, right, and kind of talk. This 1/2 then gets distributed. Since I'm multiplying in here, I can distribute this 1/2 exponent to all of my terms. So I go ahead and do that first. And then I can simplify. I see I have several x's and several y's, so I go ahead and combine the terms there that I have and just come up with those fractions. Then I can go ahead and say this one's negative, so it needs to move to the other side of my fraction. Okay, so now that I'm here, I am left with 1x and 1y. These fractions are as simple as possible, so I know I'm done. So let's look at our next example. So first thing I notice is I've got this negative exponent, and I don't like negative exponents, so to make that positive, I flip the fraction. Then I can split these into pieces, right, because I'm dividing. So now I have y to the 2/3 times to the third, and then 2x to the 1/3 to the third. Now that I have those simplified, I can take my exponent and distribute that in, since I'm only multiplying or dividing, and simplify my fractions. Okay, and here's kind of that third example that we're looking at. So again, I can kind of simplify in here and then deal with my 1/2 later, right? Because this is going to be distributed to all of the different pieces. So the first thing we did here was we combined my x's and y's, right? So I had an x in the numerator and an x in the denominator, and y's in both places as well. So first we combined those using our properties of exponents. Then we went ahead and kind of simplified, and then we'll distribute this 1/2, this exponent. And I can distribute here because I'm only multiplying or dividing, and then I can simplify and solve from there. Okay. So now we're going to be writing an expression as a single quotient, right? Because I'm doing a lot of different math here, I want to simplify it and make it as easy as possible. Okay. So here we go. The first thing we can do is kind of simplify. We'll see here I have a 2 in the denominator because it's a fraction, and a 2 in the numerator, so that can go away. So now again, I can multiply these two terms together. So I'm going to have my x squared in the numerator, and then what this is going to be in the denominator, because I want to get rid of this negative exponent. So to make a negative exponent positive, I move it to the denominator. Well, so now I'm adding. So now I can go back to when I was adding rational expressions. I have to come up with my common denominator and be able to get that to my common denominator. Well, so now that I'm there, I can simplify some terms because I have several terms in the numerator and the denominator that can be simplified. And then I write my absolutely simplified answer at the end. All right, here we're also going to look at an example of factoring, so kind of working the other way. So the first thing I notice is that I'm dealing with one fraction and one whole number. So at first I want to get everything to have a common denominator. So that's going to be my first step, right? So I leave this kind of alone, my first term. I just write the whole thing over 3, and I can do that because I'm just multiplying. Then my second term, I need to have that out of 3 as well. So I know that 2 is the same thing as 6 divided by 3. Well, so now that I have common denominators, I can go ahead and add those two numerators together. And then I am able to pull out and factor out things that I see. So I see that all of my terms have a 2, and all of my terms have an x to the third. So I can pull that as well. And then I can just go through and simplify what I have left. to get my final answer. So the first thing when factoring is always make sure that I get fractions with this common denominator first, and then I can combine terms and factor out anything that's common between them. So now we're going to look back at our learning targets, which we're working with nth roots, and that n is anything really other than a 2. We then simplified radicals. We rationalized denominators, and we want to rationalize that any time there's a radical in the denominator. We looked at solving some radical equations, and then we simplified expressions with rational exponents. We also factored them to simplify them. So now that we've gone through all of these learning targets, go ahead and work on your homework for this section.